So I'm going to talk to you a little bit, of course, about the agenda. What we're going to do today, we're going to discuss, of course, the fact that disasters do happen. We're going to talk about the trade-offs from various replication scenarios that you will have to use. We're also going to talk about a geo-distributed Galera cluster. I mean, that is possibly one of the best ways to be fully distributed. Also talk about the architecture, your disaster recovery plan, and is asynchronous the best solution in the end for disaster recovery? It may very well be, and of course, nothing like this would be complete without giving you lots of resources as well, because it's such a lengthy topic, well worth delving into. So there could be multiple reasons for planning for disaster recovery. So for one, we could have environmental reasons where you end up in a situation where there's, flooding, hurricanes, tornadoes. So, in an example here, but the floods can happen via Hurricane Sandy, where, about 8 New York data centers were struggling with connectivity service issues during Hurricane Sandy. Flooding basically submerged and destroyed the site's diesel pumps, preventing the fuel from being pumped to the generators on the level above. So that was a clear environmental problem. You also find that there are biological problems. I guess all of you are fairly familiar with the fact that we are living through life with COVID, and that can also potentially, you could have biological issues that affect availability, and you need disaster recovery plans and scenarios around it. And then there's also, of course, deliberate problems where disaster recovery comes into place, like maybe there's some kind of fraud, a bomb threat, and so forth. There's also the utilities issues where you lose power or telecom services. So even in a data center, you could potentially lose all of this. Equipment breakdown is fairly common. Can't obtain spare parts. There could be a lockdown, and during a lockdown, it may be hard for you to get spare parts. I think you're all fairly aware that supply chains have been fairly affected as well. And then it could also be, the usual hardware failures, cybercrime that causes disaster recovery. Could be data centers burning down even. So you've got a little example on the corner here where, in Korea, Samsung smart TVs around the world became fairly dumb for a while. Phones that use the S-chat service were gone. And if you were in South Korea for 1 week, the American Express service, you couldn't use your American Express credit card, charge card, because they partnered with Samsung, and the network was gone for a week basically. Then you've got the likes of fires in California. They taken O'Reilly.com down a while ago as an example. Now it's very, very hot in California, Portland, New York. They're telling you obviously to conserve your energy, not use the air conditioning too much. So overall, yeah, I'd say lots of issues overall that could affect you. And then the last thing that could require you to have disaster recovery is the fact that your machines could be seized by law enforcement. So if you'd like to have a highly available service, and you happen to also store things, say in the US, your machines could be seized if, for whatever suspected crime there was, and then, you could still have your sites running on a remote server somewhere else without any issue, really. So, yeah, multiple, I guess, options for you as to why disaster recovery makes sense, why there's so many different types of disasters. I obviously think it's fairly important for you to remember that you may be wanting a 5.9 uptime. That's 5.25 minutes worth of downtime maximum every year. That's not a lot of um, downtime, so to speak. And Galera can give you this definitely if you're willing to invest in your Galera infrastructure, of course. So again, choices are really yours. They have a lot to do with business considerations, how much you can afford, and so forth, of course. So depending on levels of affordability as well, and different types of replication, asynchronous replication should more or less give you 3 nines worth of uptime. That loosely translates to having only 8.76 hours worth of downtime a year. If you throw in a framework like automatic failover framework, you could potentially also get something similar. But Galera can give you 5 nines uptime. Nothing in the MySQL world will more or less promise you a 6 9 uptime, because I guess even from the time you detect failure, failover, even NDB cluster doesn't promise a 6 9 uptime. It's mostly a 5 9 uptime. But that's not to say you can't get 6 9s, or you can't even get 5 9s with, say, regular asynchronous replication. After all, let's be clear, your machines don't really fail all that often. Replication is fairly robust nowadays as well. So I wouldn't spend too much time and worry about it. But your SLAs are, of course, important and something you do need to, you know, work with your other teams with for. So, plenty of business considerations out there, right, that tell you you want the highest uptime, but there's also, of course, the cost on business impact, the risk management. You also want to store your data offsite. So keeping a disaster recovery plan is really all a lot about trade-offs. So there's scalability trade-offs where you're, potentially worried about agility, the resilience trade-offs where you're looking at flappy networks. Flappy networks are really bad for Galera, by the way. So you don't want that in any way, shape, or form. The hardware failures. How do you reconcile when there's a failure? And reliability is fairly important. You're worried about outage protection, continuity of business, integrity of data, performance. You always want to be very close to your users. So this is extremely true when you're dealing with multiple data centers. You want to keep your applications, your proxy, all those layers nearby each other. Of course, distributed load balancing. Again, a reasonably competent proxy can help you quite well here as well. So when it comes to Galera cluster, it's well worth noting. We talk a lot about high availability. We do talk a lot about multi-master application. Galera is a true multi-master cluster solution, so you can have each node being equal. It is we talk about synchronous clusters to ensure that you're always available, highly available even. So a few things we need to talk about, of course. One of them is quorum-based failure handling. This is how Galera actually works, and it was brought to my attention that maybe not everybody realizes this is how Galera works. So it's I guess for me it's well worth having to. Oy, what happened there? For me, it's well worth ensuring that we talk a little bit about it, mostly because Galera requires you to have a minimum of 3 nodes running at any given point of time. And this is because of the quorum algorithm that Galera makes use of. A lot of people wonder, why can't we just have a 2-node Galera cluster? And the reality is we don't, again, because of the weighted quorum that we make use of. So you don't want your cluster to split into multiple components during network failure, because then it's hard to determine which one's the primary component if you only have 2 nodes. So primary component recovery is turned on by default in most modern Galera clusters. So that's pc.recovery equals on, which you can check, of course, which you can check inside of your status. So it's also worth noting that there is a weighted quorum, and you want to avoid split brain scenarios, which is why we focus on having odd number of nodes. So quite simply, there is a quorum calculation, which basically states that if you have a 3-node cluster, each node is weighted at a third, and if one node dies, there is still 2/3 of the cluster still alive. Cluster is still considered to be healthy, all is well. But if another node dies, then of course you've lost your cluster. You've only got regular MySQL, and then you'd have to bootstrap, as in a restart bootstrap when you're starting to make sure that you started a new cluster that way. So this is why we have a 3-node minimum typically to start your Galera cluster, to make sure you ensure you don't get any split brain issues and so forth. Now, this same 3-node scenario that I talk about, naturally, it works similarly well when it comes to data centers, which is again why we're here to talk to you about disaster recovery, so to speak, because it works so well with the data centers that you also, if you had 3 data centers and one data center went away, the other 2 data centers would continue running a full Galera cluster for you. So it's winning all around. And of course, Galera makes use of optimistic concurrency control to make commits. So you commit to the local node. The local node will then send it out to the other nodes, and then there'll be a certification process before you get the okay to the client. Now, this is why, again, you remember the rule of threes when it comes to Galera overall. So Galera is very read scalable, very much like your master slave setups. It's not as write scalable as you'd expect. So again, when you're doing disaster recovery planning with Galera, this is something you really have to think about. So if you're doing a lot of heavy updates, heavy inserts, maybe Galera across multiple data centers isn't the right solution, or it is. I don't know. It really depends on your situation. But we do have optimized protocols for the cloud and basically wide area networks, which we'll get into in a little bit, because that's kind of interesting. So first and foremost, let's go through a quick overview of your replication methods that are available today in your Galera cluster. You've got the asynchronous replication method. I mean, this is standard in MySQL. It's been around for a long time. It started with statement-based replication. By now, it is default row-based replication in MySQL, except in MariaDB, it's mixed mode, where it's execute statement unless it's a dangerous statement. Then it goes into a mixed mode scenario. Then it goes into a row-based scenario. Otherwise, it's mostly statement by default. So yeah, so we have asynchronous replication. So the inserts happen into the primary, or the master as we call it as well. Now, as a heads up, the master slave terminology is going away in the later releases of MariaDB and MySQL. So primary, secondary is what we're focusing on. But yes, so you more or less insert something into a primary, and it's very fast. But there's no guarantee that the secondaries receive the transaction. And of course, you have this problem that occasionally you may have secondary lag. So you actually your master may be much more ahead of the slave. And there's also the semi-synchronous replication option. Uh, this one's reasonably interesting as well. It's also what probably powers most of the internet today. Because you insert it into a primary, and at least one secondary receives the transaction at commit time. So if you lose the primary, all is well. But in this scenario as well, you need some kind of automatic failover framework. So basically, in the case of an asynchronous or semi-synchronous situation, you always end up needing some kind of framework to keep uh, things to keep your high availability going. And it's not really fully baked for disaster recovery out of the box either, as a heads up. Then there's of course the virtually synchronous Galera cluster. Uh, this one I guarantee you is extremely interesting because while you're here for Galera webinar for one, it's also multi-master application where all nodes contain the same data. No framework is needed, basically, and failure is already, the idea of a failover and is already built into the Galera cluster. So how does this all work with disaster recovery, you might wonder? So Galera cluster obviously supports being run in multiple data centers. So effectively what you do is you actually end up with a 9-node Galera cluster across 3 data centers, well geographically spread, and this can keep you very highly available. So Galera has supported geo-distributed database clusters since at least 2015. In fact, that's when we wrote our very first blog post about it. So it's definitely something that's been around and baked for some time. But you will notice, of course, that again throughout this entire webinar, we will talk about why you may want to do it and where you may not want to do it. And plenty of resources do exist naturally for getting this set up, and we might even start blogging more about it as well. So first things first, like to focus on the fact that we've got 3 nodes in each data center here. So in London we've got G1, G2, G3, and then in San Francisco we've got G4, G5, G6, and in Singapore we've got G7, 8, and 9. So we've got actually 3 nodes per data center. And the setup here is such that we keep them all these nodes are basically in sync. Now Galera has obviously got optimized network protocol such that when we write, say, to G7, for example, so in Singapore, it would actually write to G8, G9, and then it'll elect a node in either, so maybe it'll write to G3 and G6. So it writes 5 nodes per transaction, as long as we do a segment properly. And then of course, we want to ensure we keep all our time zones in UTC. So 2 things. One is keep everything in UTC. The second thing is if we configure segments correctly, we will ensure that we're only writing to the local data center plus 1 elected node elsewhere. So that is like a huge win in terms of saving your bandwidth and your round trip time. You also of course want to keep latency very low, because you can't keep it basically high. So again, we always recommend using the same data center. It's got good interconnects across multiple data centers, and maybe the hybrid cloud approach is much harder than one would think. It's better to have it in one kind of, it's like if you stick to Amazon, you stick to EC2. If you stick to Google Cloud, you stick to Google Cloud. Hybrid will give you definitely a lot more latency than you expect. So let's get quickly started. Okay, so you will notice that I have a bunch of nodes here. I've got SF nodes and London nodes, and well, of course, we do a quick select version. We're all running 8023, and more importantly, want to make sure that we're running in UTC time. Why should everything stick to UTC time? Mostly because you want to make sure that you don't have any weird replication errors caused by mismatched time zones, right? So we've got this all here. So I've got Galera 1, 2, 3, and let's find one node's IP address. So this is a node in Singapore. And if I do a ping, you'll notice that Singapore to Singapore, the ping times are actually pretty low, right? I mean, they're in the 0.4 second, millisecond situation. And from London, if I ping, say, the same node, we're looking at about 150 milliseconds. And I guess you realize that we cannot break the speed of light. And it does take time, and it's pretty consistent, right? 150 milliseconds. And if I ping from San Francisco, same IP, we're at about 173 milliseconds. So now this is all on this. It's basically DigitalOcean in this particular example, but I could have used Linode or whatever. It would make no difference. So we're actually getting pretty consistent times in terms of ping times from one machine. You'll realize that one machine is getting maybe a little better, so we can maybe even wonder why these, and we don't need to really trace route it at this stage, but it is worth noting that yes, you could run all these without much issue, and take a quick gander as to how there will be performance degradation. So so let's just pick a random node. I also want to tell you that yes, we do have another node where we just keep everything locally into a 3-node Galera cluster versus a 9-node Galera cluster. So you want to know if this is really a 9-node one. We can do a show status like wsrep, and you'll see that we have actually got a cluster size of 9. In fact, if we do, you'll see even the weighting is 9. So we have 9 in this particular cluster. Now, if you wanted to know which segment we were using, in Singapore, I've set it as segment 2. In San Francisco, we're in segment 1, and in London, we are in segment 0. So we got 0, 1, 2, 3 segments. So basically, whatever we write in either segment is going to be written 3 times into said segment, and then it will be sent to one other elected node in segment, say 0 and 2 if you wrote it in 1. Now, show databases real quick. Create database. So again, I can do this here. You'll see that it's all the same. They're all in different data centers. If I'll do create database, NAM. And if we do this again, you'll see we have NAM. And then, we can do a quick create table. In the interest of time, we, of course, do stuff like this. And then, I could use NAM here too. Typing would be a good skill. And then I could just do this. It's good to pay attention to the time. That took 1.03 seconds. This took 0.75 seconds. This took 0.88 seconds. And I could just keep on running it, right? So I'm now running it across multiple machines as a heads up. And they're actually writing to 9 nodes, well, 5 nodes, and then they're being applied to all the 9. And you'll notice that they're all in the 0.73 seconds, 0.80 second range. Sometimes you get 0.65 seconds. Now, let's create a database called NAM here. It's obviously not here. and then use nam. And I'm going to just pop this here, do the same exact thing here, and you're going to be shocked because you're going to realize that that took 0.037 seconds, right? Or 0.048 seconds. So you're looking at a much better performance where 0.7 seconds, 0.6 seconds versus 0.03 or 0.04 seconds. So that's an order of magnitude, a huge difference when you think about it, because you're like, hey, look, that this is a 3-node Galera cluster versus a 9-node Galera cluster. So there is an order of magnitude difference that you're not quite seeing when you're writing to many more nodes than you'd expect, right? So to say that you're going to get the same exact performance on an insert operation or an update operation is, of course, definitely not true. But if we do even a select count star, you'll realize that select count stars are going to be, so this is 0.010 seconds for what was that, 140,000 rows. So we 0.06 versus 0.038, 0.039. So yeah, okay, the performance is for reads also a little a tad affected, but it's likely also because we're using different server match. So the little trick is I'm actually using a new alpha release of MariaDB here for testing purposes. But overall, you can expect the selects to be quite consistent compared to insert, where you will find that it is much slower than you would expect. And that's fully expected because you can't beat the speed of light, you can't beat physics. So we do have to take into consideration, yes, these things are going to happen naturally. So yeah, that was a quick demo, more or less, on showing you that yes, we can run across multiple nodes, and we can quite happily provide you service across multiple data centers. And this 9-node setup with 3 segments is actually a very highly available Galera cluster, such that we could lose an entire data center and still be okay in terms of having the cluster operational. And I guess the other fairly quick thing, what I could vaguely do is I could even just more or less kill stuff if need be. So we don't want to kill this. So I could be inserting data here and here and here, and we have a 9-node cluster. I could do a we have a 9-node cluster here. I could I could literally kill while that's happening. And you'll see that, yes, even though I killed it, it respawned and it has picked up again from a different position. So that's the beauty of Galera right there. So the other way I could do is I could literally just hit reboot on this, for example, and I would go to an 8-node cluster for a bit. It's literally, so you notice the cluster size literally dropped down to 8. But the Galera cluster is still operational without any issue. And I could actually remove the entire London by rebooting all of London, and the cluster would still continue operating without any issue. There would be no failure or failover time during set time. You'll notice that it actually hasn't been able to restart MySQL. And it's in the recovery stage at this stage. But it most likely won't recover because I gotta turn off ST-Linux. And if I do so at 220,000 rows right now. We have 9 nodes. And if I start MySQL here, use NAM. And again, if I just copy this real quick, you'll find that it synced everything even though it was down for a while. So 140,000 at the last reboot to 230,000 syncing, no issues. And yeah, we can repeat this with constantly running data and so forth. All right. So that is a quick example across multiple data centers, which I guess is kind of useful. So there are multiple benefits of a geo-distributed Galera cluster. Well, one is you get increased redundancy. Basically, all your database operations are local via segmentation. So the penalty for synchronizing the nodes of a high latency link is only incurred at commit time. You find there are no delays between the remote nodes during the transaction itself. Because Galera is distributed locking, the row level lock doesn't have to be communicated across data centers. And in higher latency situations where the avoidance of slave lag is not required, of course you could use asynchronous replication. Network traffic, of course, is reduced across the data centers, so we've optimized the bandwidth consumption naturally. Latency penalty is also minimal as possible. So when it's time to commit, it happens. But of course, we can't defy the speed of light, and I've shown you that it does take time to ping from San Francisco to Singapore and London to Singapore and so forth. Fully control your flow control. Again, I have some examples later. No split brain issues if basically you configure it out of the box. If you do funny things to Galera, you can actually turn off split brain checking. I don't recommend all that, obviously. And then out of the box encryption. Of course, it also works with asynchronous replication naturally. So obviously, there's some configuration thoughts. Use GMcast segment for each data center. so that you basically communicate the write set only to the nodes in the cluster. And then this is set by something called WSREP provider options, where you can set things like GMcast segment equals 1. You can also set the replication windows like EVS send window, say to maybe 512, EVS user send windows, keep alive periods like 3 seconds, and suspecting timeout 30 seconds, inactive timeout 1 minute, install timeout 1 minute, and so forth. Also increase the timeouts above max round trip time. So again, when you increase your replication windows, you find that the in-flight replication is better. There's also options like WSREP sync wait. You could set that to maybe like 5 or 7 or 10. Turn on the provider options for flow control. Like you could set the FC limit to 16, the master slave to yes if you wanted to. Replication for causal reads set to 5 seconds. The EVS settings, plenty of EVS. EVS is auto eviction settings. So we document all this fairly well as well in the documentation. And the other option, of course, for many people is also use a dedicated Galera cluster network, which we also, of course, support. So you can have 2 network cards, 2 network interfaces, one just for Galera traffic. And during a recovery, what we saw just now, the recovery was very small. I mean, we went from what 140,000 to 230,000 rows. That we have what is an incremental state transfer. But if you end up doing like full state snapshot transfers and SST, you might find that you're actually using up a lot of data. You can actually saturate a link because you might be sending terabytes of data over the network card during that time. So it is actually entirely possible to saturate a network link, again, depending on how much data you are transferring across the network. So this is a quick example of how you'd configure a Galera cluster. And this, again, it's using Galera for maybe the only interesting thing here is the WSREP provider options, where I actually put a segment size. And the fact that we actually have 9 Galera cluster addresses here. So architecture-wise, if we're going to do Galera cluster, 9 Galera cluster nodes at the minimum, and you also have the application clusters in 3 data centers, you get a lot of high availability, but all this is very expensive as well. So you want to save costs, you may want to go HA cheap as possible, maybe 2 nodes in 1 data center, one another. A lot of people do weird stuff like this. You also have to ensure your schema is planned sensibly. So if you have a lot of hot rows, so you're updating the same row all the time, this is a problem. You may end up having a lot of deadlock errors. You have less tolerance to performance issues. So I've shown you that it can take you order of magnitude, 10x order of magnitude in terms of commit time for even a simple insert. Can your application bear that? I don't know. Entirely up to your application and you, of course. So I can't tell you Galera is your best solution if you have lots of updates in a typical app, and I can't say, hey, sometimes you may find you may find the ability to do maybe more read-write splitting via proxy, for example. So, but we are here to talk about disaster recovery. You got to run your business continuously without any interruptions, irrespective of any damage occurring to your infrastructure. I obviously think disaster recovery is extremely important. And disaster recovery is definitely not cheap, for sure. That's the backup cost that you're going to have to basically think about and eat. We have seen things like DRBD inside the Linux kernel, is RAID over Ethernet, but you don't really need this for your Galera clusters. There's of course also disaster recovery and Business Continuity, third edition. Very good book by Tejandra BS. And here we've got the recovery time objective, which is the time in scale, in hours or days, within which this must be achieved. So RTO is very important. This is the length of time you can afford to cease operating your business. There's also the recovery point objective, which is the point in time when an organization should recover. For example, it could be stated as data can be recovered as of 9 p.m. last night, and defines the amount of data that you can afford to lose. In anything I plan, and I hope you are planning, you will want to never lose any data. We just can't afford to lose data. It's just ridiculous overall. So I think you're really building resilience into your infrastructure. So losing no data is your key. People who do stuff in the cloud, they understand resilience quite well, if you ask me, because cards are varying quality. When you spin up a poor instance, you just basically kill restart, and as long as you know the baseline benchmarks. And if you do stuff on EC2, Amazon basically, you'll find that the Simian Army by Netflix can make you have a lot more resilient infrastructure. So you have things like Chaos Monkey, which can actually randomly just kill instances as and when you go. You have Latency Monkey, which can actually introduce latency on random nodes at any given time. And you have Chaos Gorilla, which can drop a whole availability zone. So all this like pretty interesting ways to understand and check your resilience. Also check the resilience of your Galera cluster really. So keep track of the mean time to recover. I think one thing people don't think much about is the mean time to detect the failure. So how long do you know before a disaster has struck, and how quickly can you move your workloads? Also, you need to know what is your SLA. I think that's an extremely crucial thing to remember. So, what do you need in a plan? For Galera cluster, you really are ensuring that you have another data center take over. You could be running the 3 data center cluster idea thing that I just showed you. I showed you nine nodes across 3 data centers. But for disaster recovery, sometimes many people end up thinking of asynchronous replication to another data center because it saves cost of having yet another data center. Most people can only have 2 data centers. They think, hey, I can have a 2 data center, 6 node Galera cluster setup. But we talked about having odd number of nodes, and 6 nodes if you don't really get quorum. You have to play with weights then as well. And the moment you start playing with weights is a good way to actually end up having problems like split brain scenarios later on. Of course, you want to make sure everything's 100% automated. Very, very important to not have to do things manually. So you got to think of your entire stack, right? So beyond the database, you have to ensure that there will be quick DNS switchover. You also got to ensure your application servers need to be running, ready to take over the load. At the other data center, if you're using a proxy, this has to be available at the other data centers too. And to mitigate from complete disaster and also have good performance, you have to create a replica of your setup at a remote site. So, I've given you an example of having a 3-node Galera cluster in one site. I've given you an example of having a 9-node Galera cluster across 3 data centers, spread across geographically. And, the other option that I have not shown you is, yes, you could also have the ability to use asynchronous replication between 2 data centers. And this is a diagrammatic example where you could just have between London and Singapore asynchronous replication, where the app servers, the proxies serve both London and Singapore independently. But let's just say London is primary site, Singapore is delayed by asynchronous replication. Again, asynchronous replication has been fairly robust for a very long time. It's pretty fast nowadays. We've got things like parallel replication, multiple threads that can be running. There's no reason to believe that there will be a lot of slave lag, but if there is, then in this case, say Singapore would be a little laggy, so to speak. So why async replication between data centers for disaster recovery? Well, so on top of the fact that we've been talking a lot about geographical dispersed solutions, we have to remember that TCP/IP magnifies the effect of write-set transmission as well as latencies. So you have nodes not residing on the same physical network delay for all the certification commit phases for a certain amount of time. certain amount of time definitely is not, it's not just really predictable. It could be like, certain amount of speed of light given distance. And you can't, predict the transmission time of a set of data that's split into several datagrams sent over the internet. So that we don't really have trustable measures. So as I said earlier, I think asynchronous replication is fairly robust, and maybe fully synchronous replication is not right for your application in all scenarios. So if you are going to use async, make sure you do turn on the binary logs via log bin log slave updates, which is fairly important. And you should enable binary logging on at least two of the cluster nodes, because you're building the slave as normal from one of them. I recommend just enabling them on all, because it's easy for you to then do change master if need be as well. But again, this requires some kind of manual glue. It's an automated framework. Eve Todo has a replication monitor manager solution that one could use for this sort of thing. And then there's of course this that's open source. There's of course a cluster control that's not open source but also fully available for you to use. And I like to refer to a friend of mine, Mark Callahan. He's got Callahan's law. Basically, in a Galera cluster, any given row that can't be modified more than once per round trip time, which I think is a fairly decent law to remember. There's also practical case study. So basically, Marco Tusa has got a few blog posts and one very recent YouTube link where the effect is unpredictable delay and reads the network issue from Galera. Nodes can be evicted from a cluster, which is what can happen. And then when we experience this, you get some bad unspecified network issues. So then whenever you need a solution based on a tightly coupled database, can't locate the nodes at a distance that is longer than the largest round trip time of our shortest desired period of commit. So yeah, fairly important stuff to remember. So there are some simple reasons as to what you end up wanting to do. Galera gives you several sets of parameters to control flow. I've talked about this already. You have the controls for right side cache as well as the ability for the way nodes engage and disengage for flow control. You can of course realize again three data centers pricier than usual. So the other scenario is to maybe occasionally use just maybe 7 nodes instead of 9. Latencies matter, all kinds of latencies. You may think 5 milliseconds doesn't matter, but actually it is very high. So imagine doing 170 milliseconds as well. This is again why the network protocol has to be very optimized. And yeah, we can control like IP frames as well, configure them like jumbo frames and so forth. But yeah, you just gotta remember flow control, receive queue. Of course, all of this doesn't absolve you from the other things like, what kind of automatic failover framework do you have when you go asynchronous for disaster recovery? What's a good backup restore solution? Previously, pretty much everything, including our documentation till today, recommends use HA proxy. But HA proxy doesn't understand the SQL protocol, whereas proxy SQL and MariaDB MaxScale do. So I think these are your more modern solutions which you end up using nowadays. Proxy SQL probably the preferred variant because it has no licensing issues. MaxScale, of course, has a very odd license, so maybe you want to avoid it. I also want to talk to you a little bit quickly about the Galera arbitrator daemon. GOBD. You have access to a third data center, but you don't want to put 3 nodes there. You can just put a GOBD, which just reads the traffic and discards it, basically sends it down now. This one's useful. So you now have 7 nodes instead of 9, but you do still need to have a third data center. And also if you have an even number of nodes, GOBD can function as the odd node and it can help you avoid the split brain set scenarios. And if you need a consistent application state snapshot, you can also use this for backups. Now, again, default configuration will have no split brain problems. The time where you do end up having split brain issues if you turn on things like pc.ignore_sb, ignore split brain, or pc ignore quorum, which is ignore quorum calculation. So yes, we have options for you to shoot yourself in the foot, but you should not use them. We do document them, obviously, but you should not be using them. So again, as I said, default configuration should have you quite golden. Oh, I realized we only have 8 minutes left. Actually, we're past time even, so we're going to go a little faster now. So what are your real choices for the ultimate disaster recovery? If you have the money, 3 data centers for fully secured clusters are great, except, as I said, you're not doing too many updates. Because you also do need to, expand your options for the application servers, the proxies, and so forth. But if you have minimum budget, the best option, of course, is asynchronous replication across 2 data centers. So you have 3-node Galera cluster in data center 1, 3-node Galera cluster in data center 2. Here's some kind of manual glue to have asynchronous replication between the two. When you need to do failover, it's literally some kind of manual glue. Galera 4 has come out. It's been around now for quite some time. It was included in MariaDB 10.4, obviously 10.5, and the 10.6 that I was showing you, and of course MySQL 8 and Pacona HTTP cluster 8. It comes with multiple features, but the most interesting ones for disaster recovery are the streaming replication, network resiliency, and the non-blocking DDL options. I'll go through them fairly quickly. So streaming replication is where your nodes will process the write sets in a single memory resident buffer. And previously you'd have a hard cap on transaction sizes of nothing more than 2 gigabytes in size. So we decided we got to make sure you have the ability to run larger than 2 gigabyte size transactions. And you might be thinking to yourself, why would anybody do something so crazy, right? And the simple reason is you have long running transactions is one, but the other one is low data in file. That's another fairly common thing people do. It tends to be quite large. So yeah, we have the ability for you to now do large data in files. Again, if you're writing them to 5 nodes across large latency, and eventually it starts to 9 nodes. If you're doing a lot of low data operations, I don't really think Galera might be right solution for you at that point in time. You might want to use asynchronous across the data centers. So again, streaming replication, great stuff. You can configure everything at a dynamic level. So you really just set these two options dynamically. So I guess in most situations, you don't want to be turning it on because there is, of course, replication overhead. But when you do need to, you should definitely make use of it, just not too often, especially when you have a 9-node cluster across 3 data centers. A typical chunk size is, a fragment size is around 10,000 rows. You can play around with this again, maybe even potentially up to 20,000 rows. But remember, there is a lot of excessive logging, so you will have replication overhead, and it's writing everything to the MySQL. It's writing everything to a MySQL table, so it's privileged table, and you'll find that there's something called MySQL streaming log, and you can actually take a look at the status of your streaming application as well from here. If you have poor network connections, we have this thing called cluster error voting, where now the protocol for the nodes to decide how the cluster will react to problems in replication. So when one or several nodes have an issue to apply incoming transaction, so suspect inconsistency, this feature will help. So in a 9-node Galera cluster, if 2 nodes fail to apply the transaction, they'll get removed, and a DBA can go in and fix what went wrong, so these nodes can rejoin the cluster automatically. And yeah, if we have irrecoverable errors, of course, they will be removed. MariaDB Enterprise has this other option. So another problem when you have very large amounts of nodes in your cluster is that when it's time to do a schema change, you got the option of doing total auto isolation or the RSU option. now rolling schema upgrade. But there's also the a non-blocking option, which you get in MariaDB Enterprise and likely some variant of Galera Enterprise at some stage. And this is like the best option if you can get your hands on it. But unfortunately, as I said, it's only in the MariaDB Enterprise release. So I'm only putting this here for completeness. I'm going to presume most of you don't get to use it. All right. So when it comes to a quick amount of monitoring, of course, we've got the show global status, we've got the error logs. You know, we have to monitor each node separately for maximum effect. And you want to monitor the health of the network, round trip times, bandwidth utilization, and network links between the segments. Now, ping, of course, is super easy, but iperf is very useful. And then if you're going to look at playing around with benchmarks, you know, there's TC and dropwatch that can also help you as well. But yeah, iperf is the other very useful utility to see what kind of latency you're having. I always follow the whole idea of the military, where they tell you the prior proper planning will prevent your piss poor performance. So you know, definitely plan ahead. Galera Manager. This is a screenshot of Galera Manager. We're about to release the next variant of this. Galera Manager will support having, you know, multiple segments. It will support the ability to roll out automatically inside of EC2. It's not only just one node, but also multiple segments. So, you know, I can say this stuff is you know, quite handy. So many documentation resources, right? So that, you know, from managing and configuring flow of control, the auto eviction protocol, streaming replication, how to back up a cluster, geo-distributed clusters, and a little bit more on streaming replication, which we just did. Feature deep dive, so got a good video, got a good very long blog entry on how you could use it. So I highly recommend you take a gander at what's available. There's also a couple of good books that you could read if you're interested in disaster recovery. So I recommend you take a quick look at them, and then, you know, I'm gonna take a quick stab at answering some questions, maybe not all of them, because we're basically out of time actually. But yes, we'll answer, you know, your questions again in a blog, so that should be good. So we have a question: if you lose a data center, you're down to 6 nodes. Doesn't have to be an odd number. Yes, you know, when you've lost the data center, it's similar to like when you lose a 3-node Galera cluster. You've lost one node. You now still have 2/3. So even though you have 2 nodes left, you have 2/3 out of 3. This is actually okay. So it'll continue running, but you can't lose any more than that at that point in time. So I hope that answers your question. Is there a Kubernetes operator to deploy Galera cluster on Kubernetes? So yes, there are Kubernetes operators. So Percona has an operator for Percona HDB cluster. MariaDB has an operator for MariaDB server. There is no Galera cluster one, but there are Kubernetes operators available. Ooh, there is no Galera Slack channel. There is we have a mailing list. It's at Google Groups. So if you go to Google Groups, look for Codership-team, you'll find that you could ask your questions there too. Is there a recommendation for handling unavoidable huge SSD over a wide area network? Yeah, you know, if it's a huge SSD, it's going to happen over network. Can happen over a private network card. That alone might help a little bit. But there's the thing is, we don't have the ability to control if you're going to get an IST or an SSD. So plan for an IST if possible. As explained, the minimum number of nodes is 3, but what about garb? Garb-D can act as a node, so you could have 2 nodes and have garb-D as one node as well. It's recommended to use 2 nodes and 1 Galera arbitrator. It is okay to do. So a arbitrator can actually be lower powered than the rest of your Galera. So yes, you could do that. So that the arbitrator really is just there to do voting. What are the advantages and disadvantages of a scheme like this? Well, the advantage is one, you could use, like I said, a virtual machine, maybe even a much lower powered instance. The disadvantage is you actually don't have an extra node. So if you have a 2-node Galera cluster and one GARBD node and one of the nodes dies, when you don't actually have any resiliency now in the event another node, in the event the other node dies, because GARBD doesn't do anything really. So you obviously have nothing going for you any longer. And when it's time to bring back when it's time to bring back a node, when you're joining the node, the node that is there are only 2 nodes obviously, right? Now, so because GARBD we don't count that as useful. You'll find that you can't do any operations on the donor node, which is the sole node you have. So the disadvantages are quite clear that it's better to run a 3-node minimum rather than a 2-node one GARBD situation. Is it safe to have multi-mask using 2 nodes and one GARB? Yes, it is safe. It's just not as highly available as you'd expect. Can you mix CodeShip's Galera or PXC nodes with the same exact database, Galera version, in a cluster? Uh, so yeah, PXC and Galera should be in theory okay. As long as it's not MariaDB. We don't recommend you to mix naturally. Also, the network protocol, the way Pacona ports it, it's not that Galera ports into Pacona, so there may be some mismatch sometimes. But most situations you should be able to mix Codation with Galera with PXC nodes, but definitely not the MariaDB with Codeship or PXC. But yeah, we could totally take a quick look at this. This is a good question, actually. Maybe even one worthy of a blog post or something. So, with that, thank you for all the questions.